Hello everyone and welcome back. This is my second video for CTP2. This video will be covering carbon dioxide sensor and radio frequency modules used in this project. In the beginning model of my project, I had not included the carbon dioxide sensor and the radio frequency module. But as I progressed further in my project, my supervisor advised me to add these parts into the system as it would enhance the system and make it more efficient and productive. Carbon dioxide sensor. We all know that carbon dioxide is a crucial ingredient required for plant growth. Secondly, carbon dioxide is an important factor to be considered and controlled in a greenhouse since it has the ability to improve yield and quality of crops. Third point, CO2 sensor isn't available in Proteus. Therefore, a variable resistor is used as carbon dioxide sensor and is coded to perform in the same manner. Radio frequency technology. The first point here explains what an RF module basically is. It is a small electronic device used to transmit or receive radio signals between two devices. Next, an RF sensor consists of a transmitter and a receiver. RF modules help us in sending and receiving the data wirelessly up to a certain distance, the maximum distance being 500 feet. This offers ease in wireless data transferring. Radio frequency is one of these technologies that can be availed at a much less cost and works quite well for small scale projects. These modules are really easy to deal with as they just require the data to be transferred serially. Circuit to measure carbon dioxide sensor. This is a screenshot of the simulated circuit. The components which I have used are receiver and transmitter, variable resistor, motor, servo motor, and L293D motor driver. Now, let's look at the working simulation of the circuit. This is the simulated circuit. The circuit is designed in such a way that a variable resistor is used instead of carbon dioxide sensor to detect the carbon dioxide level. According to the mechanism in the circuit, an alert pops up in the system when concentration of carbon dioxide exceeds 600 ppm or goes below 300 ppm. The carbon dioxide sensor is coded to change the voltage level, which in turn changes the concentration. The level of concentration controls the carbon dioxide valve. When the concentration is above the defined level, the carbon dioxide valve closes and the ventilation flaps open. When the carbon dioxide level is between these defined levels, both the valve and the ventilation windows are closed to keep the carbon dioxide level intact. Throughout this whole procedure, continuous alert of the live data is sent to the owner or the operator and it contains the data of all parameters. This is done using radio frequency technology where a receiver is used to obtain the data from the carbon dioxide sensor, which is then sent to the transmitter, which is located where the operator is located. The operator will receive the data showcasing status of the level of carbon dioxide in the greenhouse. This is my code for the carbon dioxide sensor. Now, coming back to the presentation, In the next video, I will be combining all the sensors together in Proteus and along with the required code. This implies that the complete system will be working together as one. I will also talk about further improvements and finally conclude this research project. These are the references I have used for this part of the project. Thank you for watching my video.